Yes, class. Am I audible to all of you? Fia, Hafsa, Deborah. Yes, class. Am I
Yes.
audible?
Yes, ma'am.
What about you both? Fia, Deborah, are you able to hear?
Yes, ma'am.
All right. So yesterday in the last class, we had completed the basics of electric charge, and these basics are important. These are part of your syllabus only. So we had seen electric charge as the basic property, and it gives rise to various phenomena. This we had seen, and we had seen it's the transfer of electrons that occur, not the transfer of protons or neutrons which occurs. Now, when the transfer of electrons occur, it makes a body neutral or negatively charged or positively charged. So there are three methods which we had studied. First method was charging by friction. Second method was charging by conduction. And third method was charging by induction. In friction, you actually rub two objects. In conduction, you just place the objects together. And in charging by induction, you bring up a glass rod with the charge which you want to isolate. Questions are also there from charging by induction, charging by friction, and charging by friction and conduction. We have practiced the questions. So yesterday only. So charging by induction, the question is there. See, before that, no, in charging by induction, you have to have a concept of earthing. So have you people heard of it before? Earthing basically means that charges are moving. You have connected a conductor with the earth. Suppose human body is a conductor. If you touch something, electrons, that's why we say, no, human body is a good conductor. So we have to be careful with the electronics, electric equipments, electrical circuits. So if you by chance touch any of those, so electrons will flow from your body towards the earth, because your body is a conductor. But right now we are not focusing on conductor, we are focusing on the process in which these electrons are moving back to the earth. That is what is meant by this. That process is known as earthing. We call this process as earthing. If a body is positively charged, then from earth the electrons will come out. And suppose if, let's say, the body is negatively charged, so electrons will flow from the body to the earth. This is what you have to remember when we talk about earthing. These two things, these are sufficient for you to remember. So when a body is connected, potential I'll not talk about here, because potential you have a separate lesson, but just keep it in your mind. For potential becomes zero. What exactly is potential, that I'll tell you in the next lesson only. So there this topic will become clearer. But why are we studying this is that you have certain questions where you have to make a body completely isolated. Like this is given, a sphere is given, this is kept on an insulating stand, and the question is, make this isolated sphere as positively charged. Right now what is happening? The sphere is completely so these are the sphere. This is the first case. All the positive charges and all the negative charges, these are balancing. Let me draw it separately so that this becomes very clear. So we have kept it on an insulating stand. Positive, negative charges both are balancing, so the object is neutral. Now we have to make the object as positively charged, right? So let me make the glass rod as negatively charged. So I have brought a glass rod, and this glass rod is negatively charged. This is the glass rod, and this is negatively charged. Now what happens? All the positive charges will be attracted towards one end, and negative charges, they will remain on the opposite side. All the positive charges, they will be attracted on this side, and the negative charges, they'll be on the opposite side. Now what will happen? Now what will I do? With the glass rod in continuation only, I'll keep the glass rod here. I'll not remove it, because if I'll remove what I told you in the last class, it will nullify it, it will become neutral, back to normal, and I do not need normal right now. So I'll hold it. While holding, I'll have all the positive charges and I'll earth it. This is the symbol for earthing. This is the symbol for earthing. Means I have connected to the earth. So all the electrons have drained out, right? Now, even if I remove the rod, this is just full of positive charges. Now remove the rod. In your sphere, there are only positively charged ions present. So this is how we have converted a neutral sphere as positively charged. All right. Note it down from here. Then we'll see certain properties of charges. That is also Now coming to the properties of charges. So out of all the properties, one property is very important, that is quantization of charge, that I'll tell you. First, additive nature of charge means you can add all the charges, that is plus 2 Coulomb, plus 3 Coulomb, minus 1 Coulomb, minus 2 Coulomb, because charge is a scalar quantity. Scalar quantities, you can directly add them. All right. Scalars and vectors, you must have done it in your class 11. So it's a scalar quantity, so you can algebraically add it, no need for your vector addition. All right, so just simply add and subtract. This is 5 minus 3, you get 2 Coulomb of charge. Nextly, net charge on body is algebraic sum of individual charges. Now charges are conservative in nature. See, what did we study yesterday? We had seen that electrons were getting transferred from one object. You had one atom, you had from one atom to another atom. So it was the transfer of electrons that occurred, right? So if the electrons are getting transferred, it means no electrons are being created by itself. So it's just the transfer of electrons that occurs. So net charge throughout your system will remain the same. This will help you in your calculations where you're not able to find out the quantity. Always remember the net charge will be the same. Invariance of charge means charge doesn't depend upon speed. This means, see, for example, if a vehicle is there, this is carrying a charge 3 Coulomb. This has started moving with velocity 1 meter per second, slowly. Then the same vehicle has increased its speed, let's say 5 meters per second. Even if the speed has increased to 5 meters per second, the charge will remain 3 Coulomb. This means charge doesn't depend upon the speed. It is independent of speed. So these are the very basic properties which you have to remember. Now, this is very important, quantization of charge. Mark this as important. This has to be done separately, in detail. Questions are there in your NCERT and questions will come from this, and this will be used till the end. You will be using the formula of this. No, you will be having number of electrons which you have to relate in your questions, whether current electricity, till current electricity, at least it will be used throughout. Then EMI, AC, that time also it will be used. So see, what does it mean? See, for the amount of charge that an electron is holding, one single electron is holding 1.6 into 10 to the power minus 19 Coulomb of charge. So what is the amount of charge that 2 electrons are holding? 2 electronic charge, right? 2 into 1.6 into 10 to the power minus 19 Coulomb. That is 3.2 into 10 to the power minus 19 Coulomb. Double, right? If I give you 3 electrons, what will be the amount of charge? 3 times the same thing. 3 electronic charge, it would become 3 into 1.6 into 10 to the power minus 19 Coulomb. If I give you 4 charges, this will be 4 times electronic charge. That is 4 into 1.6 into 10 to the power minus 19. Are you seeing this pattern? 1, then 2, then 3, then 4. It means charges have a pattern. They are always, even if I give you nth charge, that will be n times the electronic charge. This is the basic formula, very basic formula, which will be helpful throughout. Q is equal to NE. E is the electronic charge, which is 1.6 into 10 to the power minus 19 Coulomb. N is the number of charges. And Q is the total charge. Q is equal to NE. So charges are integral multiple of this number, 1.6 into 10 to the power minus 19. That is E. They are integral multiple of this E. That is what we call as quantization of charge. So all observable charges in nature, they are integral multiple of E. E is 1.6 into 10 to the power minus 19 Coulomb. All right, this is what we mean when we say quantization of charge. So if 4 electrons are there, suppose 1 electron has moved over here. So the amount of electron that is moving, no. Let's say the net charge on this body has become 0. But if you notice over here, from here, 1 electron has moved. Let's say I have taken this and I have shifted this here also. Let's say I have taken this and I have shifted this here also. So how many electrons am I able to share? 1, 2, then 3, then 4. Am I able to share 0.5 electrons, or am I able to share 1/4 of electron? No. Minimum number of electron that is possible for sharing is 1. Then second most number that is possible is 2. There is nothing in between this. This is what is meant by integral multiple. Integral multiple of 1.6 into 10 to the power minus 19. One or two questions let's see from this topic means this. Numericals are there from quantization of charge. Note down the properties. See, this question says calculate number of electrons corresponding to 1 coulomb of charge. So value of charge is given to you as 1 coulomb. Number of electrons we do not know. And electronic charge we know 1.6 into 10 to the power minus 19 coulomb. So Q is equal to NE we will apply. We have to find out N. This is missing. We know Q, we know E. So number of electrons will be charge divided by electronic charge. So that becomes what is the amount of charge? 1 coulomb by electronic charge is 1.6 into 10 to the power minus 19. So remember this value because 1 over 1.6 into 10 to the power minus 19 will be used. So 6.25 into 10 to the power 18. This is the number of electrons that will be obtained. Note down this question. Recorded lecture of this class which you are attending. Why? Okay. Regarding that fear, you have to talk to the management operation team. From where you get the link, to talk to them. They'll send you. They edit the video and they send it. Okay, just talk to them. They'll share it. All right, now see, yes, talking about Coulomb's law. So Coulomb's law, you have Coulomb's law means, see, if there are two charges present, Q1 is present and Q2, there are two charges present in your system and they are separated by a certain amount of distance. Let's say they are separated by r distance. Now we have to find out what is the magnitude of this force. So the electric force between these two charges, this is proportional to two things which you have to remember. Firstly, this is directly proportional to the product of, means Q1 multiplied by Q2, product of the magnitude of these charges. Means even if you have minus, you will not include it because we are considering the magnitude only. So this is Q1 into Q2, the magnitude, product of magnitudes of both the charges. Product of magnitudes of both the charges. F is equal to, is directly proportional to Q1 into Q2. Product of magnitude means, suppose you have one charge as -4 Coulomb, second charge you have +3 Coulomb. So their magnitudes product will be 4 into 3, that is 12 only, not -4 into 3. You won't take -12 as the answer. It will be 4 into 3 itself. Or if you are given both this as 4 Coulomb, this as 3 Coulomb, still this will be 4 into 3, that is 12 only. So because you are considering the magnitude. Secondly, whatever is the separation between them, this is inversely proportional to square of the separation. Inversely proportional to the square of their separation. Means it is inversely proportional to R square. See, if you combine them, F is directly proportional to Q1, Q2 by R square. Now remove the proportionality sign. What do you get? K, Q1, Q2 by R square. This is the formula of electric force magnitude. Now, what about this constant K? So see, this constant K, this is written as 1 over 4 pi, and a new symbol you have, which is epsilon naught. This means permittivity. How much force is there depending upon a medium. Suppose if you have both the charges, you have taken the charges in air only. So the forces will have a certain magnitude. If you dip the charges in water, force's magnitude will change. If you dip the charges in oil, the magnitude of force between them will change. So depending upon the different types of media that are present, different materials that are present, we have different magnitudes of force. So how much force will be changed? How much force is being changed because of presence of a particular media? So the governance of force's magnitude because of change in media is controlled by this quantity which we call permittivity, this epsilon naught symbol. When we talk about air or vacuum, we put a naught over here. That becomes epsilon naught. The symbol is epsilon. This symbol. So we put a naught, that becomes epsilon naught. It means we are referring to permittivity of air or vacuum. See, for permittivity of air, you remember this value, 8.85 into 10 to the power minus 12 C square per Newton per meter square, means Coulomb square per Newton per meter square. This value you have to remember. This is actually calculated experimentally, the value of permittivity. For any other medium, you don't have to remember. For no other medium, you have to remember. You just have to remember it for air or vacuum. That is air. Air only you have to remember, which is 8.85 into 10 to the power minus 12. This value will not be given to you. This you have to remember. See, if we substitute all the value, 4 we know. What is pi? 3.14. What is epsilon naught? 8.85 into 10 to the power minus 12. When we solve this, we get the value 10 into 10 to the power 9. This is the value of the constant that we substitute in Coulomb's law. K, your value of K is 9 into 10 to the power 9. This is what is your Coulomb's law. All right. Now talking about this K, we call this as a dielectric constant. Regarding this dielectric constant, we have a separate segment over here. We'll discuss it, but first note down the basics of Coulomb's law. Coulomb's law statement, if it is asked, Coulomb's law means, according to Coulomb's law, you have to answer that electric force between 2-point charges is directly proportional to magnitude, product of magnitudes of both the charges, and inversely proportional to square of the separation between them. What I have written in bits, you have to write it all together. That is your Coulomb's law. Note it down. See
Ma'am,
now, yes.
when finding the force, we have to substitute this value in K, Q1, Q2 by R
Yes,
square.
yes. You have to see. Now you don't need to substitute no 4 pi, then value of epsilon naught. You already have this value calculated 9 into 10 to the power 9. So every time when you are calculating the force, you have to put in the value as 9 into 10 to the power 9, the value of
Yes.
K. If you know this value, you know 4 pi, you can find out this value also. But I'll tell you for epsilon naught and the value of K, these two remember. These two remember these values, and I'll ask you in any day. Whenever this is needed, I'll ask you people because these two are very important. And sometimes you have specific questions in your those entrances which you have no after class 12th. There one question was there where epsilon naught was actually asked. So these values, if you remember, that saves a lot of time, and in your CBSE syllabus also that is included. What you have to, what you do not have to remember is if in any medium it is given. This is saying no dielectric. This is saying the question is dielectric constant or relative permittivity. Suppose different medium is used. This is we are talking about air. Q1 is there, Q2 is there, they are separated by a certain distance. So force in air will be Q1, Q2, 1 over 4 pi epsilon naught R square, or you can write this as K Q1, Q2 divided by R square. But you can put in the value of K always whenever it is needed. All right. Now see, when we talk about a particular medium, let's say this is a different medium that is given. So there do not put epsilon naught because epsilon naught is valid only for air. For a different medium, substitute it as epsilon. This governs the dependency of force on a medium. So how will you solve now the questions now? See, epsilon by epsilon naught, the ratio of epsilon to epsilon naught gives you relative permittivity. Now, epsilon you do not know. Epsilon naught, you know. You only know this quantity. So how will you substitute? What you are going to do? Just remember one thing. There sometimes definition of relative permittivity is also asked. So relative permittivity is ratio of epsilon in air to epsilon in medium to epsilon in air. Epsilon in medium to epsilon in air. All right. Now, when we, the same thing is also your dielectric constant K. The same constant, 9 into 10 to the power 9, we have studied same constant. This is your dielectric constant. The same constant epsilon by epsilon naught. So what will you do? You know relative permittivity and dielectric constant are physically different because this is just the ratio of two quantities. This is just the ratio of the epsilons. But dielectric constant itself has a separate meaning. When we'll do capacitance, this will have a greater significance. There I'll tell you what are the details about dielectric constant. But for Coulomb's law, this is sufficient. It's also ratio. Mathematically, both are same. Mathematically, the formula is same. But physically, both have a different meaning. All right. Like in many formulas we see like pressure is force per unit area, stress is also force per unit area, but physically both are different, right? Similarly here the formula is same, but physically both are different. Mathematical formula is same, physical meaning is different. Epsilon R is nothing, it's just a relative term. It's just a term to define epsilon by epsilon naught. It doesn't have a particular meaning. But K, dielectric constant, has a particular meaning. It tells you, firstly, it has a relation 1 over 4 pi epsilon naught. Apart from this, when we'll see capacitance, there you will see between the capacitor plate, dielectric medium is substituted, which actually helps in the formation of capacitance. So that's why I'm not bringing in that term, otherwise it will become confusing. Now, epsilon naught, you know, dielectric constant, you know. What you can write epsilon as? Epsilon naught into K. Now, what is your formula of force? Suppose a question comes, a medium comes which you are not aware of. So force in air was K. Let me write it as in terms of epsilon naught. Q1, Q2 by 4 pi epsilon naught. In a different medium, you will write Q1, Q2, 4 pi. Instead of epsilon naught, what you will write? K times epsilon naught. So it means force, how can you write? Force in medium by K. This is actually a relation if we try to establish. Look here. You Q1, Q2 over 4 pi epsilon naught. This is the force in air. So the force in any medium, this becomes force in air divided by K. This is also a relation, and this is asked in Vivas also. You have your Viva, you have a project also in your class 12. So in Viva, this is asked, and the confusing part becomes when we talk about K, whether it's F naught over Fm. F naught means force in air over force in medium, or force in a particular medium over force in air. So remember this relation that K will be force in air by force in medium. But when we talk about epsilon by epsilon naught, air one will come downwards in the denominator here. But when we talk about force, epsilon naught comes over here. Air one comes in the numerator. Fine. So these are the properties of dielectric constant. Regarding dielectric constant, this is actually used in capacitors, formation of capacitor. That time we'll study in dielectric constant. But right now, dielectric constant is just a constant which you have to remember, and its relation with a different medium. Note it down.
Ma'am, there should be R square also in the formula, right? In
Priya, you are asking something?
Ma'am, there should be R square also in the formula, right? Q1, Q2 by 4 pi epsilon 0
Oh,
into
yes, yes.
R.
This R square is there. This R square is right, right, Hafsa.
Okay.
This R square is present. It's just that by mistake I didn't write. R square will be there in the formula. All right. Done till here, class. All right. Now, see certain properties of Coulomb's law. Let us discuss that. So Coulomb's law, yes, this is a very important property that Coulomb's law is valid only for point charges or spheres. Either you have point charges, Q1, Q2, or you have spheres. Coulomb's law is valid only for these. All right. If anything is different from here, Coulomb's law is not valid. You do not have a square charge for which you are applying Coulomb's law. This is very specific for Coulomb's law. Second, it is valid only if both the charges are static or at least one of them is static. It means distance between them should not change. This means if both the charges are moving, so both the charges should be what it is written. See, static or at least one of them is static. Means if both are moving, your Coulomb's law is not valid. If both are at rest, Coulomb's law is valid. But one more condition it is defining, at least one of them is static. So this is only possible in a circular path. See, if one charge, this is static, one of them is static, and the other charge, Q2, this is moving in a circle. See, second will be moving and first one will be static over here. This is the case. Or best is both of them are static, none of them are. But if they have started their motion, then charges, your Coulomb's law won't be applied. It's a conservative force, means your work done is independent of the path traveled. It just depends upon the initial and final position. And it's a central force, means because it acts on the line joining the center of these two charges. It acts when you apply Coulomb's law, both the charges are intact. You have to consider both the charges. All right. Note down the properties. Here, what is meant by a magnitude? Fia, what do we mean by a magnitude? Fia, I'm not audible to you. Quantity number. So if I give you -3 Coulomb, Q1 is 2 microcoulomb, that is 2 into 10 to the power -6 Coulomb. Q2, if I give you -3, what is the magnitude among -3? What is the magnitude over here? -3 millicoulomb. What is the magnitude? Fia. That I'll tell you later, but what I'm asking, answer that first. That I'll tell you. This is -3 millicoulombs. Forget millicoulombs. I'm just saying this is -3. What is the magnitude? You told me no quantity number. What is the magnitude? Minus sign will come. See, Fia, this is the issue where you are getting the wrong answer. If I give you -3, magnitude is only 3. If I give you -4, magnitude is only 4. If I give you +3, still magnitude is only 3. Magnitude means you are eliminating the number. It means you have not understood the initial portion of the class. Coulomb's law's basic statement was that magnitude is considered. See, magnitude, this was what was I was telling to you. Even if you have -4, you will consider it as 4. Even if you have +4, you will consider it as 4, because we take the magnitude only. So magnitude means from now onwards, do not commit this error, because your entire answer will be wrong. Magnitude means you're just taking the number itself, ignoring the signs. All right. Yes, and coming to why it is 10 to the power -6, 1 micro is equal to 10 to the power -6. So 2 microcoulomb will become 2 into 10 to the power -6. The way 1 milli is 10 to the power -3. So we write this as 3 into 10 to the power -3 coulomb. This is 3 millicoulomb, that becomes 3 into 10 to the power -3 coulomb. And radius is 3 millimeters. Again, we will convert milli 10 to the power -3 meters. Now put it into the formula K Q1 Q2 by R square. K 9 into 10 to the power 9. See, Hafsa, this is how we have to put in the value 9 into 10 to the power 9. Q1 is 2 into 10 to the power -6. Q2 is 3 into 10 to the power -3. R square, that is 9 into 10 to the power -6. 9 will get cancelled. This will get cancelled. 3 into 2 is 6. 6 into 10 to the power 6 Newton. That is our answer. Note it down. All right, so -6 won't come. What was your magnitude, Fia? -6 into 10 to the power 9. How 9? Just check. Now I think it's clear. It's clear now. And what about you both? Deborah, you're silent today, the class. Understood?
Yes, ma'am.
So the question says that two charges Q1 and Q2, they are placed at separation R, repel each other with a force F. It means you have Q1, Q2, separation is R and the force is F. It means K Q1 Q2 divided by R square. So the force is F. Then it says calculate the forces if magnitude of both the charges is doubled and separation is half. It means if it was Q1, this becomes 2Q1, this becomes 2Q2. Magnitude is doubled and separation is half, R by 2. Now you have to find out the force. So F dash will be what? So this will be K 2Q1, 2Q2 divided by R by 2 whole square. This is now the formula which you have, right? K Q1, Q2 by R square. Now see, let's write this properly. This becomes, this is 4 Q1, Q2, R by 2 whole square. See, R by 2 whole square. That makes this as R square, this as 4. So this 4, this becomes R square by 4. 4 will go up. So F prime will become 4 into 4. This 4 will go up. 4 into 4. K Q1 Q2 by R square. Now see class. What is K Q1 Q2 by R square? This was the force in air F which we had started, with which we had started the question with this. So F prime will become 16 times the force. This is the answer. 16 times the force. F prime is equal to 16. Note down this also quickly.
Done, ma'am.
Text me done once you have completed till here. Deborah has completed. What about Hafsa? Now you people have to log into your accounts already. If you people have completed, very good. So this completes with Coulomb's law. A very big topic has been completed and a very important law. Log into your accounts and please attempt your after class assessment. In the last class, Fia, Hafsa, both of you didn't attempt. Deborah also, I think she didn't attempt. So attempt your after class assessment. Okay, class. Thank you so much. Let's meet the next weekend.